Popcorn is a favorite snack around the world, but have you ever wondered what actually makes it pop? Behind that satisfying pop is a combination of physics and thermodynamics. Let's investigate the science transforming a hard kernel into the fluffy treat we enjoy, from heat transfer to pressure building. Heat transfer and thermodynamics. The core of the popcorn process is heat transfer. When you apply heat to the kernels, the heat is transferred through conduction, meaning it passes from the hot pan or popcorn machine directly to the kernels. As the kernels heat up, the water inside them starts to gain energy. This is where the first law of thermodynamics comes into play. Energy isn't created or destroyed, but transferred. Now, as the temperature rises, the second law of thermodynamics kicks in, which states that heat flows from hot to cold. The water inside the kernels absorbs the heat, gradually turning into steam. This leads to a phase change. The water inside the kernel transforms from liquid to gas. 2. Phase change and pressure buildup. As the water inside each kernel reaches its boiling point, it turns into steam, causing a phase change from liquid to gas. According to the kinetic molecular theory, gas molecules need more space than liquids, so they begin to move rapidly and collide with the inside walls of the kernel, generating pressure. 3. The role of the ideal gas law. The relationship between heat, pressure, and gas can be explained by the ideal gas law, PV-nRT. In this equation, P is pressure, V is volume, N is the number of gas molecules, R is the ideal gas constant, and T is temperature. As the water inside the kernel turns into steam, the number of gas molecules increases. Since the kernel's volume is fixed and the temperature is rising, the pressure inside the kernel escalates. Eventually, the shell can no longer contain this pressure and it bursts open. 4. Expansion and pop. The moment the kernel bursts, the starch inside rapidly expands and cools, flipping the kernel inside out. This is the explosion that gives popcorn its fluffy appearance. Essentially, the heat and pressure have forced the kernel's soft interior to inflate, turning it into the snack we enjoy. Popcorn changes very interesting way in just a few minutes that shows important ideas in physics like heat transfer, phase changes, and gas laws. It is a great example of how daily activities are deeply connected to the fields of thermodynamics and molecular behavior. Now you know that popcorn is more than simply a snack. It's a demonstration of the laws of physics.